9.16. The last version of DirectX supported for Windows 98 and ME is 9.0c. Support for Microsoft Internet Explorer running on any Windows 9X system has also since ended. Internet Explorer 5.5 with Service Pack 2 is the last version of Internet Explorer compatible with Windows 95, and Internet Explorer 6 with Service Pack 1 is the last version compatible with Windows 98 and ME. 17. Internet Explorer 7. The first major update to Internet Explorer 6 in half a decade, was only available for Windows XP SP2 and Windows Vista. The Windows Update website continued to be available for Windows 98, Windows 98 SE, and Windows ME after their end of support date. Windows Update was never available for Windows 95. However, during 2011, Microsoft retired the Windows Update v4 website and removed the updates for Windows 98, Windows 98 SE, and Windows ME from its servers. 18. 19. Microsoft announced in July 2019 that the Microsoft Internet Games services on Windows ME and XP would end on the 31st of July 2019. 20. The growing number of important updates caused by the end of service life of these pieces of software have slowly made Windows 9X even less practical for everyday use. Today, even open source projects such as Mozilla Firefox will not run on Windows 9X without rework. 21. RetroZilla is a fork of Gecko 1.8.1 aimed at bringing improved compatibility on the modern web for versions of Windows as old as Windows 95 and NT 4.0. 22. The latest version, 2.2, was released in February 2019 and added support for TLS 1.2. 23. Design. Kernel. Windows 9X is a series of hybrid 16/32-bit operating systems. Like most operating systems, Windows 9X consists of kernel space and user space memory. Although Windows 9X features some memory protection, it does not protect the first megabyte of memory from userland applications for compatibility reasons. This area of memory contains code critical to the functioning of the operating system, and by writing into this area of memory an application can crash or freeze the operating system. This was a source of instability as faulty applications could accidentally write into this region, potentially corrupting important operating system memory, which usually resulted in some form of system error and halt. 24. User mode. The user mode parts of Windows 9X consist of three subsystems: the Win16 subsystem, the Win32 subsystem, and MS-DOS. 25. Windows 9X/ME set aside two blocks of 64 kilobytes memory regions for GDI and heap resources. By running multiple applications with numerous GDI elements, or by running applications over a long span of time, it could exhaust these memory areas. If free system resources dropped below 10%, Windows would become unstable and likely crash. 26. Kernel mode. The kernel mode parts consist of the Virtual Machine Manager, VMM, the Installable File System Manager, IFShop, the Configuration Manager, and in Windows 98 and later, the WDM Driver Manager, DKERN. 27. As a 32-bit operating system, virtual memory space is 4 GB, divided into a lower 2 GB for applications and an upper 2 GB for kernel per process. Registry. Like Windows NT, Windows 9X stores user-specific and configuration-specific settings in a large information database called the Windows Registry. Hardware-specific settings are also stored in the registry, and many device drivers use the registry to load configuration data. Previous versions of Windows used files such as autoexec.bat, config.system, win.ini, system.ini and other files with an .ini extension to maintain configuration settings. As Windows became more complex and incorporated more features, .ini files became too unwieldy for the limitations of the then current FAT file system. Backwards compatibility with .ini files was maintained until Windows XP succeeded the 9X and Entlines. Although Microsoft discourages using .ini files in favor of registry entries, a large number of applications, particularly 16-bit Windows-based applications, still use .ini files. Windows 9X supports .ini files solely for compatibility with those applications and related tools, such as setup programs. The autoexec.bat and config.system files also still exist for compatibility with real-mode system components and to allow users to change certain default system settings such as the path environment variable. The registry consists of two files, user.that and system.that. In Windows ME, classes.that was added. Virtual Machine Manager. The Virtual Machine Manager, VMM, is the 32-bit protected mode kernel at the core of Windows 9X. Its primary responsibility is to create, run, monitor and terminate virtual machines. The VMM provides services that manage memory, processes, interrupts and protection faults. The VMM works with virtual devices, loadable kernel modules, which consist mostly of 32-bit Ring 0 or kernel mode code, but may include other types of code, such as a 16-bit real mode initialization segment, to allow those virtual devices to intercept interrupts and faults to control the access that an application has to hardware devices and installed software. Both the VMM and virtual device drivers run in a single, 32-bit, flat model address space at privilege level 0, also called Ring 0. The VMM provides multi-threaded, preemptive multitasking. It runs multiple applications simultaneously by sharing CPU, central processing unit, time between threads in which the applications and virtual machines run. The VMM is also responsible for creating MS-DOS environments for system processes and Windows applications that still need to run in MS-DOS mode. It is the replacement for Win386.exe in Windows 3.x, and the file vmm32.vxd is a compressed archive containing most of the core VXD, including vmm.vxd itself and ifsmp.vxd, which facilitates file system access without the need to call the real mode file system code of the DOS kernel. Software support. Unicode. Partial support for Unicode can be installed on Windows 9X through the Microsoft layer for Unicode. File systems. Windows 9X does not natively support NTFS or HPFS, but there are third-party solutions which allow Windows 9X to have read-only access to NTFS volumes. Early versions of Windows 95 did not support FAT32. Like Windows for Workgroups 3.11, Windows 9X provides support for 32-bit file access based on IFSHLP. System, and unlike Windows 3.x, Windows 9X has support for the FAT file system, allowing file names with a maximum of 255 characters instead of having 8.3 file names. Event logging and tracing. Also, there is no support for event logging and tracing or error reporting, which the Windows NT family of operating systems has, although software like Norton Crash Guard can be used to achieve similar capabilities on Windows 9X. Security. Windows 9X is designed as a single-user system. Thus, the security model is much less effective than thin in Windows NT. One reason for this is the FAT file systems, including FAT12/FAT16/FAT32, are the only ones that Windows 9X supports officially, though Windows NT also supports FAT12 and FAT16. but not FAT32, and Windows 9X can be extended to read and write NTFS volumes using third-party installable file system drivers. FAT systems have very limited security. Every user that has access to a FAT drive also has access to all files on that drive. The FAT file systems provide no access control lists and file system level encryption like NTFS.28. Some operating systems that were available at the same time as Windows 9X are either multi-user or have multiple user accounts with different access privileges, which allows important system files, such as the kernel image, to be immutable under most user accounts. In contrast, while Windows 95 and later operating systems offer the option of having profiles for multiple users, they have no concept of access privileges, making them roughly equivalent to a single user, single account operating system. This means that all processes can modify all files on the system that aren't open, in addition to being able to modify the boot sector and perform other low-level hard drive modifications. This enables viruses and other clandestinely installed software to integrate themselves with the operating system in a way that is difficult for ordinary users to detect or undo. The profile support in the Windows 9X family is meant for convenience only, unless some registry keys are modified. The system can be accessed by pressing cancel at login, even if all profiles have a password. Windows 95's default login dialog box also allows new user profiles to be created without having to log in first. Users and software can render the operating system unable to function by deleting or overwriting important system files from the hard disk. Users and software are also free to change configuration files in such a way that the operating system is unable to boot or properly function. Installation software often replaced and deleted system files without properly checking if the file was still in use or of a newer version. This created a phenomenon often referred to as DLL hell. Windows Me introduced system file protection and system restore to handle common problems caused by this issue. Network sharing. Windows 9X offers share-level access control security for file and printer sharing, as well as user-level access control if a Windows NT-based operating system is available on the network. 29. In contrast, Windows NT-based operating systems offer only user-level access control but integrated with the operating system's own user account security mechanism. Hardware support. Drivers. Device drivers in Windows 9X can be virtual device drivers or, starting with Windows 98, WDM drivers. VXDS usually have the file name extension .vxd or .386, whereas WDM compatible drivers usually use ith extension .system. The 32-bit VXD message server, MSGSRv32, is a program that is able to load virtual device drivers, VXDS, at startup and then handle communication with the drivers. Additionally, the message server performs several background functions, including loading the Windows shell, such as Explorer.exe or Progman.exe. 30. Another type of device drivers are .drv drivers. These drivers are loaded in user mode, and are commonly used to control devices such as multimedia devices. To provide access to these devices, a dynamic link library is required, such as msystem.dll. Windows 9X retains backwards compatibility with many drivers made for Windows 3.x and MS-DOS. Using MS-DOS drivers can limit performance and stability due to their use of conventional memory and need to run in real mode, which requires the CPU to switch in and out of protected mode. Drivers written for Windows 9X /Windows Me are loaded into the same address space as the kernel. This means that drivers can by accident or design overwrite critical sections of the operating system. Doing this can lead to system crashes, freezes and disk corruption. Faulty operating system drivers were a source of instability for the operating system. Other monolithic and hybrid kernels, like Linux and Windows NT, are also susceptible to malfunctioning drivers impeding the kernel's operation. Often the software developers of drivers and applications had insufficient experience with creating programs for the new system, thus causing many errors which have been generally described as system errors by users, even if the error is not caused by parts of Windows or DOS. Microsoft has repeatedly designed the Windows driver architecture since the release of Windows 95 as a result. CPU and bus technologies. Windows 9X has no native support for hyperthreading, data execution prevention, symmetric multiprocessing, or multi-core processors. Windows 9X has no native support for SATA host bus adapters, and neither did Windows 2000 nor Windows XP, or USB drives, except Windows Me. There are, however, many SATA I controllers for which Windows 98/Me drivers exist, and USB mass storage support has been added to Windows 95 OS R2 and Windows 98 through third-party drivers. 31.32 Hardware driver support for Windows 98/Me began to decline in 2005, most notably for motherboard chipsets and video cards. Early versions of Windows 95 had no support for USB or AGP acceleration. MS-DOS. Windows 95 was able to reduce the role of MS-DOS in Windows much further than had been done in Windows 3.1x and earlier. According to Microsoft developer Raymond Chen, MS-DOS served two purposes in Windows 95, as the bootloader, and as the 16-bit legacy device driver layer. 33 When Windows 95 started up, MS-DOS loaded, processed config.system, launched command.com, ran autoexec.bat and finally ran win.com. The Win.com program used MS-DOS to load the Virtual Machine Manager, read system.ini, load the virtual device drivers, and then turn off any running copies of EMM386 and switch into protected mode. Once in protected mode, the virtual device drivers, VXDS, transferred all state information from MS-DOS to the 32-bit file system manager, and then shut off MS-DOS. These VXDS allow Windows 9X to interact with hardware resources directly, as providing low-level functionalities such as 32-bit disk access and memory management. All future file system operations would get routed to the 32-bit file system manager. 33 In Windows Me, Win.com was no longer executed during the startup process. Instead it went directly to execute VMM32.vxd from io.system. The second role of MS-DOS, as the 16-bit legacy device driver layer, was as a backward compatibility tool for running DOS programs in Windows. Many MS-DOS programs and device drivers interacted with DOS in a low-level way, for example, by patching low-level BIOS interrupts such as int13h, the low-level disk I/O interrupt. When a program issued an int21h call to access MS-DOS, the call would go first to the 32-bit file system manager, which would attempt to detect this sort of patching. If it detects that the program has tried to hook into DOS, it will jump back into the 16-bit code to let the hook run. A 16-bit driver called ifsmgr.system would previously have been loaded by config.system, the job of which was to hook MS-DOS first before the other drivers and programs got a chance, then jump from 16-bit code back into 32-bit code, when the DOS program had finished, to let the 32-bit file system manager continue its work. 33 According to Windows developer Raymond Chen, MS-DOS was just an extremely elaborate decoy. Any 16-bit drivers and programs would patch or hook what they thought was the real MS-DOS, but which was in reality just a decoy. If the 32-bit file system manager detected that somebody bought the decoy, it told the decoy to quack. 33. MS-DOS virtualization. Windows 9